Welcome and hello. This is a video exercise in HEC ResSim, and in this exercise, we're going to be dealing with utility scripting, which I've also recently learned is also called static scripting. We're going to write a script and do some post-processing on some data after we create a network and then run a simulation. All right, what I have on the screen here is my ResSim. I'm in the watershed setup module, and then I'm going to start from the beginning and take you through step by step to show you how this all works. So let's start off by going File, New Watershed, and then go ahead and type in a name that you want for your watershed here in the name field. Okay, in location, go ahead and select the location that you want that watershed directory to be saved to or created in, and then open, and then select your units, and then the time zone, and then click Apply, and then OK. Okay. All right, so the watershed has been created. The name is up here in the window title. And let's go ahead and zoom in. Click the Stream Alignment tool, hold down the Control key, and then single left click. Continue holding down the Control key, and then just keep clicking. I'm going to go this way with it. And then before your last click, let go of the Control key and one final click. Give your stream alignment a name. Click the Computation Point tool, hold down Control, single left click. I'm going to call this CP1, and then select your reservoir tool. I'm going to hold down Control, single left click on the upstream end of the dam, and then let go of Control, another single left click further downstream. I'm going to call that reservoir 1, and then let's just add one more computation point at the bottom to be complete, CP4. All right, then next I'm going to go Watershed Configuration Editor, Configuration New. I'll just call it config1, and then select the time step, which is not used by ResSim. Apply, OK. And then let's file and save watershed. All right, next let's go ahead and switch the module to reservoir network. Now, the first thing we want to do here is create a network. So I'm going to go up to network and then new. Select config1 or whatever you named your configuration you just saved in the previous step from this configuration dropdown. That will bring in the reservoir and the junctions. Let's call this network 1. You can call your network whatever you want, but just give it the name right there, new. And then to connect the network, let's select the reach tool here over in the left tool menu, hold down Control and then single left click on the upstream junction, let go of Control, and then single left click on the downstream junction. Give the reach a name, click OK. I just like to use the suggested name, that's fine. And we're good there. We go to network and then save. Next, I need to define an inflow at this upstream junction, or CP1 or CP2, doesn't matter. And then I'm going to edit the reservoir, and then we'll create an alternative. So first things first, I'm going to click the junction tool, right click, edit junction properties. I'm on CP1 here. And then I'm going to click local inflow. And then on the first row, I'll say inflow at CP1, factor of 1, apply, and OK. Next, let's go ahead and actually create the inflow time series dataset. So that'll be all ready for us. So to do so, let's go up to Tools, HEC DSS View, File, New. I'm going to call this time series data.dss. So that DSS file has been created right here. Next, I'm going to go Data Entry, Manual Time Series. I'm going to call this Project Location Flow 1 hour H1. Start date, this is going to be for the month of July 2024. So I'm going to go 01 July 2024. The first hour is 100 hours because I'm going with a 1 hour time step. And then the units will be CFS, type will be instantaneous value. Okay, down here in the values, I just went over to Excel and copied the hourly values onto my clipboard. So now I'm just going to go paste. And then here are the records. We're going to start at 2000 CFS here, and then it's going to oscillate around 2000. Let's go ahead and just click save. I'll show you what that looks like. So I'm selecting that record we just created and clicking this plot button. And here is that inflow. It starts at 2000 and it just kind of goes up and down. So yeah, we can close DSS view. We'll reassign that inflow to CP1 a little bit later. Before we do, though, let's go ahead and select the reservoir tool and then right-click, Edit Reservoir Properties. Over here in the pool, I'm going to select that first record there and then right-click, Paste. As I had that data copied onto my clipboard, I just went into Excel and did that. The base elevation is 1350, and then the top elevation is 1500. So over in dam, I'm going to type in 1500 here. The top of dam length, I'm just going to make something up here, 500 feet. Sure. And then over on the dam, I'm going to right click, add controlled outlet. I can also do that from this top menu here if I select the dam and then I click add controlled outlet. So that gave me a controlled outlet. Next, I'm going to paste in the data, Control V. I had copied onto my clipboard from Excel. It shows the max capacity versus elevation. And then I'm actually going to say there's 3 gates. So the total max capacity would be 3 times the max capacity. All the other settings I'll just leave as they are and then click apply. Next, over in the operations tab of the reservoir editor, I'm going to go operations new. And then I'm going to call this operation set 1 and then click OK. And it gives me my different zones. So I'm going to define the top of zone elevation as 1500. Apply. The inactive zone is going to have a top of 1400 feet. And then conservation zone, this is going to serve as my guide curve elevation zone, the top of zone will. This is something I'm going to vary for the simulation. So usually I'll use 1480 or 1450. I'm going to start at a bottom elevation of 1440. And you'll see where I'm going with this because we're going to come back and change that value. But to start off, it's going to be 1440. And then I'm going to increment it 10 feet for the next total of 5 trials. So I'm going to go 1450, 60, 70, and 80. The very first one will be 1440. We'll work our way up to 1480. All right, so we're going to start with 1440. I want to create a couple rules now. And the first one is going to be a max 2000 CFS year round. The focus of this exercise is not on the rules or the zones per se. So I wanted to kind of keep things simple here. It'll be a function release rule of the date. Like I said, a maximum and 2000. Apply. All right, let's add that rule to all zones. And then let's add another rule, which will be a minimum of 1500 CFS. It will be a controlled outlet release function. Okay. Based on date, year round, minimum, and 1500 apply. And then also add rule to all zones and apply. Okay, that looks good. Let's go ahead and create an alternative. So I'll click OK here. Let me save the network because we made some changes to the reservoir. Alternative, edit. Okay, then alternative, new. I'm just going to call this base for the base case based on network 1. That's good. For time step, I'm going to select 1 hour and then leave all the other settings the same. Operation set, I'll select my operation set 1. Look back here. What I'm going to do is select 1440 for my starting elevation because that is what I assigned to be the guide curve elevation. And then for the flow, I'm going to start it at 2000 CFS, which is the inflow value for the first few hours of that, the time series that we assigned to CP1, which we need to do right now. So I'll click on the time series. Here's the inflow at CP1. Now we need to make that connection between that junction and the actual data. So I'll select the record, then I'll click this Select DSS Path button, navigate to that file. Here it is, open, then select the record. It's the only record in our DSS file, and then click this Set Path Name button. So what that did was it made that assignment so we can go ahead and save and close our alternative. All right, so I'm going to go network, save the watershed, sure, and then module simulation. So let's create a simulation and then see what happens here. Simulation 1, and then, like I said, this is going to be for July 2024. I'm going to start the simulation on the 2nd hour of the month, and then the look back period will be the 1st hour, and then this simulation will end on the 31st, which is the last day of the month. Okay, I'll select the base alternative and then click OK. My network popped into place over here in the main display. And the simulation tree now shows my simulation name and my alternative. So I'm going to compute. And then that ran. That's great. let's go ahead and just peek at the plot real quick before we move on. So what we have here is two plots. On top, it's the water surface elevation based on the different zones you can see, and then below it's the flow. So let me highlight the top plot. We can see the water surface elevation starts at 1440, guide curve elevation. It goes up to 1460, and then it goes down, and then up again, and then finally down. So those that variation is based on the flows, of course, which is the bottom plot. We have our inflow, which you see here in the black bold line, and then the release from the reservoir is the green line down here. So it's either almost always governed by that maximum of 2000 CFS rule or the minimum of 1500 CFS rule, pretty much every time step. So what I want to do in the next four trials, I'm going to create a trial, call this 1440. It'll just be the same as the main alternative. So that trial 0, trial 1. Then for trials 2 through 5, I want to increase that guide curve elevation to 1450, 1460, 70, and 80. And then we're going to go ahead and write a script like this exercise is about. It's writing a script to do some calculations on the elevation of the water over the course of the month here of July 2024. So hang with me. I'm going to show you what I'm doing here. Trial. So what I'm going to do, I'm going to create a trial based on that alternative. I'm going to call it guide curve equals 1440 feet. Okay. I'm going to run that, even though it's the exact same thing. Now I have the results saved for trial 1 that way. Now what I want to do is create a new trial. This is going to be the same thing except 1450, 1450. Okay. And okay. Now I'm going to make some edits to 1450. So I'm going to edit run reservoirs. The two things I need to change are the guide curve elevation in the zone, which is the top elevation of the conservation zone. So that'll be 1450. Apply. Okay. The other thing I need to do is change the look back data from 1440 to 1450. And then I will save that. Everything else is the same. The inflow is the same. The pool geometry is the same. I'll click OK, and then I will compute that trial 2 for the 1450 guide curve elevation. It ran. Now what I want to do is compare these two results by looking at the plot of the reservoir together, just to kind of get an idea of what happened. Here's the plot. Let's actually look at the bottom plot first, and it's the same thing for both trials. Here's the inflow, and then here's the outflow, the release from the reservoir for trial 1 at 1440. And then in red, it's the release. It's the same thing for 1450. On the top, this is a little bit more interesting. We have the green line, which we saw last time. That's the water surface elevation in the reservoir pool over the course of the month for the 1440 guide curve. And then here's trial 2, which is the same thing, but for the 1450 guide curve elevation. So it's just it's up a little bit higher and has a basically the same shape. I wouldn't say it's parallel, but it's almost parallel to the 1440 line. Okay. So what I'm going to do now, and I'm going to sort of abbreviate the video, but I'm going to do the same thing, but instead of 1450, it's going to be 1460, 70, 80, and then we'll get into the scripting. Okay, let's go ahead and look at the results from all those plot, and let's maximize the screen. There's really not a whole lot to look at in this bottom plot, so I'm going to plot, select variables, right click on that bottom plot, which is plot region 2, remove, okay, or apply. Yeah, same thing. Now we're looking at the water surface elevation for those 5 trials, 1440 up to 1480 by stepping up 10 feet at a time. This is the data that we're going to use in our script that we're going to write to identify what is the maximum and the minimum and the range of values for the water surface in the reservoir pool over the course of this month. And I want to see like how the range changes as with regard to the guide curve elevation. So give that some thought about how the range may change and how sensitive it may be based on that guide curve elevation. All right, so let's head over to Tools and then Script Editor. I'm going to right click on Simulation, New Script. So my script is going into the simulation directory here. I'll call this Elevation Ranges. And then I'm going to type in or paste in a description here, how the water surface elevation range is affected by the guide curve elevation. All right. Okay, the first thing I want to do is use some import statements. I'm not going to use these ones here. I'm going to use these. I don't even know if I need math, but yeah, if you're following along, these are the import modules I'm importing. Okay, down here I want to find my DSS file. So what I'm going to do is type in the path for my DSS file for the file name here, and then it will be opened up and saved as a DSS file. So to do that, I'm going to come over to Tools, HEC DSS View. This right here is the DSS file name that will be used for gathering up that data. In fact, the data is already in here and saved under Pool Elevation, but I'll be back for that in just a moment. Okay, so let's go to the script and then paste that in here. It needs to be in a string. Okay, so there's my DSS file. Okay, next I want to get the elevation data sets for each of the 5 trials we did. So these are time series data sets, elevation data sets, and then I'm going to paste in some code I used here. What I need to start off with is get the path, and then the rest of this code should work. This is just for the 1440 trial. So what I'm doing here will be repeated for the others as well. But let's go back to that DSS view window and then navigate to the pool elevation. So we have reservoir pool elevation here. Trial 0 is the alternative. And then when you see a dash 1, 2, 3, 4, 5, that refers to the 5 trials. So 1440 is for trial 1, 1450 is for trial 2, and so on. So what I want to do is right click, and I think this might be the fastest way to do it, rename. And then I'm just going to highlight and then copy this path name, Control C. It's now on my clipboard. I'll just hit cancel and then minimize that screen. Come back over here and then paste that in, close quote. So that's my path that I'm going to use. And everything else should be pretty straightforward. What I'm doing is on line 13 here is I'm getting the data set. And then 14, 15, and 16 is to get the minimum value, the maximum value, and then the range is just that difference, the max minus the min. Again, like I said, this is only for the 1440 guide curve elevation, so that's why you're seeing 1440 listed here. And what you may imagine is happening next is I'm pasting in the same records, but for trials 2, 3, 4, and 5, which is for elevations 1450 through 1480. Exact same logic and code and organization that I did for 1440. All right, I'm going to come down to the bottom, give myself some lines to work with here. Next, I'm going to add the lists data. Now, this data is lists in Python that I'm preparing and are going to be required for input when creating a paired data set. So I've got my trials 1 through 5. That's just what's going to be my independent variable. And then I have minimum elevation for the 5 trials. And then I've got the guide curve elevation. It's just fixed there. And then a maximum elevation, which is the maximum value. And then finally, the last one is a range. So all these lists have 5 records because we're going to have 5 different rows in our table to compare. Further down, I'm just going to paste the rest of the code in here. So starting on line 49 or 51. So this is what I just pasted in. What I'm doing is I'm creating a paired data container. This is going to be used to create our paired data set. So there's the object. I'm giving it a name. The trials, this is just going to be the X values. So that's 1 through 5. And then the Y values, see, I'm going to have 4 different series as well. In a previous exercise, I think I did one, but for only 1 series. This now has 4. So I'm going to be tracking the elevation, min, the guide curve elevation, max elevation, and then the elevation range. and their values are all going to be in feet. So I've listed that out in the labels right here. And then, yeah, 4 different series data. And then we're writing the DSS file, and then we're closing it. And my last line of here is just basically a message box to say script completed. So we're either going to see a script completed on the screen, or we're going to see an error message. Let's hope it's the former. All right, I think we're good. Let's go ahead and save this and then run it. But I don't want to run it here. I want to actually run it in the interface. So let's minimize that. And then I'm going to go up to Tools, Script. Here is the hard script. If I click Elevation Range, then it would run, but I'm going to add it to the panel by clicking that, click Add, OK. And now it shows up down here towards the bottom of the screen, in the bottom right. So let's click it, see what happens. OK, script completed. That's what I wanted to see. So there's no syntax errors. Let's go ahead and check our simulation data here. And I'm going to clear this filter for part B. I don't see it. It should say results. Okay, let me go ahead and click view and then refresh. And then, okay, there are the results. And let's go ahead and take a look at the table data. So here are our values for the elevation. We have 1, 2, 3, 4, and 5 for our trials. And then our guide curve elevation is 1440, 1450, 1460, 1470, and 1480. And then to the left and the right of that guide curve elevation is our minimum and maximum values, which you can see are below the guide curve elevation and above the guide curve elevation. But the most important and interesting part of the data, for me at least, is this range. And what we notice is that even though the DS, the storage deviation from the guide curve elevation storage volume, is the same for all of these trials over the course of the July 2024, we're seeing that there's a much larger change in elevation range for the lower guide curve elevations. So for 1440, the max range, or the range is 37.2 feet, which is pretty extreme because it's a high of 1459 and a low of 1422. I'm just rounding these to the nearest tenth of a foot. And then the least sensitive would, of course, be the highest guide curve elevation. That's 1480, and it ranges for 13.7 feet of elevation range over the course of this 1-month simulation. So there's another exercise in HEC ResSim using the utility scripts or static scripts to take some data from a simulation, do some post-processing, and write it here to a table. I could have also written to a console log or to a dialog box or to an Excel file, but I just wanted to write this to a paired data set so you can see what that looks like here in HEC ResSim.